I'm Julie Fry, Professor of Chemistry and Environmental Studies at Reed College. My research is focused on understanding what's in the air we breathe, specifically the atmospheric chemical reactions that produce particulate matter, or haze. We're interested in improving understanding of what controls atmospheric particulate matter, both from the standpoint of its potential impacts on human health and on global climate. As a chemist, I'm particularly interested in teasing out the complex chemical mechanisms of atmospheric reactions. So here is a reaction that has absolutely nothing to do with my research, but yay, chemistry! And as an interdisciplinary scholar, I'm especially interested in making measurements and answering questions that can be most useful to policymakers. So Senator, I hope you now have all the information you need to understand the potential effects of an indirect source rule on diesel emissions. During normal times, my students and I are working on a wide range of projects related to improving understanding of atmospheric particulate matter. We simulate the atmosphere in a Teflon bag chamber in the lab and measure the products of controlled reactions. We conduct field studies to investigate the composition of particulate matter in the real world, and we use computer models and analysis of satellite and monitoring data to interpret the mechanisms and fates of atmospheric pollutants. I can show you one of our research instruments because I grabbed it from the lab when COVID-19 sent us all home. This ethylometer, which is here sampling out the window in our living room in downtown Portland, it measures black carbon, which is one of the major components of diesel particulate matter. It's an optical absorption measurement on this filter tape here because black carbon is literally dark colored and therefore absorbs light. So we use that to quantify the amount of diesel particulate matter in the air. So with this, we'll be able to see the effect on diesel particulate matter concentrations of the dramatic decrease in vehicle traffic that accompanied the stay home, stay safe order. So here's what some of that data looks like. As you can see, diesel particulate matter concentrations came down immediately after Governor Brown's stay home, stay safe order, but we're still under that order now. And as you can see, the black carbon particulate matter concentrations are beginning to creep back up. This is probably because construction never fully shut down, and that's a major source of diesel pollution in Portland. So as traffic begins to come back and things change over the next months, I'll be keeping an eye on this data and looking for information about traffic and meteorology. Rain and wind can affect particulate matter composition. And so with students this summer, I'll be doing a full analysis of this data set. Another student researcher will work with me on analyzing correlations between satellite observations of nitrogen oxides, another major vehicle combustion emission, and particulate matter. Another will work on computer modeling of some atmospheric chamber simulation experiments we ran with collaborators at UC Irvine over the past year. And another will work on analyzing data from a new network of particulate matter monitors that have recently been installed at US embassies around the world. Two other students will work on developing methods for filter collection and offline analysis of particulate matter and figuring out what kind of low-cost sensor we can deploy on a drone to get vertical profile information in preparation for a future field study of particulate matter composition in the Columbia River Gorge, downwind of a coal plant and cattle farm. In a couple weeks, we will all start working together on these projects remotely via Zoom, like all of life these days. And I hope that as the state opens up later this summer, some of us will be able to safely return to work running chamber experiments in the lab and collecting data all over Portland and the Gorge. It's an interesting moment in Portland air quality and an opportunity to learn how much cleaner we could be. So I hope to be able to give you a personal tour of my real lab sometime soon, but in the meantime, please feel free to reach out to me by email with any questions. Be well and breathe deeply while the air is cleaner.